Oh no, I lost the video to yesterday. But last year's is on there. Okay, today I would say if I had to, this is probably the most difficult objective to understand if you aren't here. Okay? But it is difficult as well. But the last class got it, and lots got their homework done in class. So if you just really listen and really play along well, you're going to get it. And that's always but this one would easily be, I think, we're almost doing the entire trig unit in one question, okay? Now, if you look at this chart, you should know all of those. Okay, and you know how to read a chart, right? You just go down, like sine 60 is root 3 over 2, right? That's quadrant 1, and most of you have it memorized in radians. Now, the difficult thing about today is I'm going to be looking for the exact answer of what's sine 15 degrees. Or what is cos 75 degrees. Okay? Now, the obvious question right now is, whoa, you said everything we need to know is on the unit circle this year. And it is. Okay? You have to use your unit circle to be able to get those. So, if you don't know your unit circle, after today, you will say, I really need to go learn my unit circle. I'm never going to get these without knowing my unit circle. Okay? So, even when you're doing these, have your unit circle out. Now, you're going, but I'm supposed to have it memorized, the whole thing. You do have it memorized. You have it that if you came, you would get it written down on a piece of paper, and then you're going to use it. Okay? I do highly recommend that procedure for your diploma. And many of you took advantage of it on last exam. And the amount of errors were minimal. Okay? With an 89% average, someone knew their unit circle. Okay? So, yeah, have it out, because when we're like, hey, what's sine this, cos that, and you're going to be like, whoa, how'd they know that? You can just look at your unit circle, and you're going to be good. So today, I'm going to teach you how to do sine 75 or cos 15. Okay? Now, the way we're going to do that is by going to the next page. And here are 4 formulas that you need to memorize. And there are 2 more at the bottom that you need to memorize. Now that's what I would be saying those 20 years ago. But, of course, after I graduated, someone had the wisdom to say, you know what? Memorizing formulas like that doesn't really show what they know for math. Let's just give them a formula sheet. Okay? Of course, that's after I'm done the course. And of course, after I'm done the course, that's when they say, hey, you know what we should take? Why are we going to make them do math all day? Why are we going to make them do like written response for 3 hours in the morning and then multiple choice for 3 hours in the afternoon? Let's just do multiple choice. Okay? Of course, they make those decisions after I'm done. Okay? So you guys don't have to memorize these forms, but I remember this. Like, do you see? Look at sine. It's like sine A plus B. Okay, sine, there's a plus. For sine minus, there's a minus. Okay, for cos, there's a plus here, there's a minus. Okay, so cos is opposite. Okay, and if it's minus, that's a plus. Okay, this is sine A, cos, this is cos, okay, and minus, well, okay, keep that straight. So you're like walking into your test and someone goes, hey, like, what time is it? You're like, shut up. I got to get in this exam. I got to get this stuff written down. So it really sucked. I'm not going to sugarcoat it. So I'm glad, actually, that you don't have to memorize these formulas. But it's kind of like, hey, here's a better tool. And you're like, hey, that's relief. but you forget about your tool, or you don't even, or you lost it. It's kind of useless now. Okay, so I'm going to teach you how to use this, and it is the hardest thing I think that you will have to figure out is how to make that angle. So how do you, like, what are two things I know on the unit circle that get 75? Hey, well, 30 and 45. I know 30 and 45, so I could use this formula. If I need to find the sine of 75, I will do sine of 35 plus 45. Yep. No, there will not be those on the exam. But you'd be pretty creative and you can get them, right? And as you see as we go through these, you'll be like, oh, wow, you really got to know a lot of trig to do that question, okay? So you'll see as we do these. When we get down here, those are the tan ones, and they're fun because they have fractions, and we all love fractions, right? So, you know, those just say fun. It's like if you're having a party, you'd want that, like a banner around. I mean, if it was an awesome party, not a lame one. Okay, so the best way we're going to learn how to do these is to do them, okay? And I'll tell you again, well, you know, here it is, here it goes, but you need to practice these. If you're struggling right now, it's because you're not practicing. And you know another thing that I would have killed for is that solution manual when I was going through these, okay? We had nothing. We had, there's the answer. You're like, oh, yeah, that's great. You have like 10 steps to get there, and I'm just going to get there with the answer. So you're going to hopefully wean yourself off that thing when you're doing questions, but you need them to help you. Yep. Yeah, snowstorms. Yeah, yeah. No, actually, my parents had that, right? I was like 3 blocks from school. Sometimes I even drove. That's how hard life was. Yeah. Well, if you're going somewhere after school, like downtown. Right? Yeah, exactly. Right? You know, that's how I rationalized it. Okay, so let's do one. Express 15 degrees as a difference of 2 special angles, hence determine the exact value of sine 15. Okay? Now, you know how I told you that at one point radians are going to be easier than degrees? Yeah, as of now. But starting now, you'll find degrees easier to do because if you look at like example 3, like example 3 is just pure mean, okay? When you see the quiz that you're going to write on Monday, I'm so glad that I'm teaching this course and I'm not taking it. That's all I can say. Okay? It's twice as hard. Twice as hard. 1960. No, I was an 80s child. Just, you know. Some people say, yeah, I was in the 80s. Like some people like 88 or what, 89. Like I was 10 years old in 1980. So from 10 to 20, I lived the 80s. Okay? I am a child of the 80s. Not these wannabe. They're like, yeah, for 1 year so they think they're an 80s person. Yeah, you'd be surprised. Someone found, and this is no lie, someone found one of my grad pictures. The Arctic, somewhere. Can't remember the name. Yes, that's why I went to school in the snow, uphill both ways. Okay, sine 15. So sine 15, 2 things you know that either add or subtract to that. Now 2 things that add to it's probably not obviously going to be the answer. But we can do 45 minus 30. That does equal 15. And I know both of those. Okay? So we're going to do, and we have to do sine. So I'm going to do sine 45 minus 30. Okay? Now, what's crucial here, because you'll see that they can get mixed up quite easy, is if you look on your formula sheet, like they use alpha and betas, but I use A and B's, right? So I'm actually going to put an A on top and a B on top of that one. That way when I go through my formula, I have the right ones with the right ones. Now, if you're looking with me here on your formula sheet, I'm doing sine A minus B. So that is the same thing as, according to this, sine A, 45 degrees, cos B, which is 30 degrees, minus cos A, which is 45 degrees, sine 30 degrees. Okay? So all I did was fill in my formula. Like whatever's an A in the formula, I put A's in, B's, I put B's in. Now, let's see how fast we can do these. What is sine 45? Root 2 over 2. What's cos 30? Root 3 over 2. Minus, what's cos 45? 2 over 2. And sine 30. Okay? This is how fast these are. This is where students, when they take diploma prep and the teacher's going through each one of them and drawing pictures, they're like, why aren't they just writing them down, right? So they always come back and they go, and it must be, I don't know if they're getting the same teacher all the time, but it must be a teacher that doesn't, work with the unit circle, because I don't think there's lots of them. But yeah, they're not that bad if you actually know unit circle. It's totally impossible if you don't. And now I'm just going to use multiplication. This is root 6 over 4. Remember, we multiply denominators. And then this is minus root 2 over 4. Okay? And this would be root 6 minus root 2 all over 4. You can't combine those anymore. That's the best you can do. Now, how is the diploma going to give this question so your calculator won't get it for you? Because you know the ones we like, right? Where they say, hey, what's sine 15? And then you just work it out and get the decimal and then put them all, like find them all A, B, C, D, see if you get the same. But this is a good numerical response. They might say your solution will be root B, or root A minus root B over C. And they'll say, what is the sum of A plus B plus C? And put it in. Okay? So in that case, your calculator will not get you the answer. But it will check it for you. Okay? So does everybody see the purpose of knowing these sum and difference? Yep. Because that's the only thing I could think of that would equal sine 15. Right? Yeah, you probably, what's another one you try though? Yeah, you know what? There's always more than one way, sometimes, but you will, yeah. You got to be easy on yourself, right? Okay, now this is where I would say maybe degrees are easier than radians, because they're asking for 5 pi over 12, okay? Now, if you haven't been to class, you probably will not even realize that's not on the unit circle, because you don't even know the unit circle, right? But for all of you, you should realize 5 pi over 12 is not on the unit circle. So I really like this question for 2 reasons. It is like, this is a 10 out of 10 difficulty scale, okay? 30% of the province would get this question. I know that, okay? I've seen other diplomas, they give something like this. This is a 30%er. Now, 2 reasons. You need to know your, how to use this. You have to know how to use your circle. Plus, they want to know what cotan 5 pi over 12 is. They're not asking for tan. They want cotan. So you even have to know how to figure that out after. Okay? So this is a good 9.5, 10 out of 10 scale. the first struggle you're going to have is what two things on the unit circle make 5, 5, or 12? Like there's no 12s on the. But again, when you do enough of these, you're like, okay, that's a common denominator of 6 and 4, which are very common on my unit circle. Over 6, over 4. So this is how I do them. I go, okay, I need something over 12, and I'm going to go plus or minus something over 12. Okay? Now the two numbers should either add to 5 or minus to 5 and reduce to something on the unit circle. Okay? Now is there two things that add to make 5 that if I reduce them, they'll be on the unit circle? 3 and 2? Okay, so if I put 3 pi and 2 pi, that reduces to pi over 4 plus pi over 6. Now if I just came out with, come on you guys, this is pi over 4 plus pi over 6, right? I know most of you would go, how did you do that? Okay, so make sure you're putting it over the denominator that they give you and put a plus or minus and do combinations like 7 minus 5, right? But 7 doesn't reduce and 5 doesn't reduce to something on the unit circle. Or sorry, 7 minus 2. 7 doesn't reduce, right? So you're going to have a little bit of trial and error, but the more you practice these, the better you will do. Okay? See, now I think I'm good to go. I need to do cotan. I don't have a cotan formula, but I will use the tan formula. And then at the end, I'm just going to flip it. Because cotan is reciprocal of tan. Okay? So if you know that, then this isn't that tough either. Because this is, again, we're filling in the blanks, right? So what is our formula? We're going to do tan pi over 4 plus pi over 6. Okay? And again, I always make the habit of doing this. And again, I tell you how to kind of prevent mistakes because I'm the one that makes them the most, right? I'm not like above you guys going, oh, you guys need to know this so you can be as good as me. And, you know, I make these mistakes all the time. So I put these things into place because I hate getting them wrong over dumb little mistakes. Okay? It's one thing if you don't know it at all. I think we even accept that. I don't even know how to do that. I didn't get the marks. But like you knew how to do it, you just screwed up A and B in one little part. Okay? So remember in the formula, wherever there's an A, I will put pi over 4, and wherever there's a B, I'm going to put pi over 6. Okay? So this is tan A. So you go tan pi over 4. You can even put the A there. Plus tan pi over 6. That's B. Yeah, that's good. All over 1 minus tan A, tan pi over 4, tan pi over 6. That's my A and that's my B. Okay? You might start to see why this is not one that many are successful on diploma. And that is why I really love this book. Okay? This book has found, these guys have found some of the greatest questions that could be on the diploma and put them into, not the homework, but into the notes. Now I'm going to do some math. I'm going to use some unit circle. Okay? So can I just substitute tan pi over 4? It's 1 plus tan pi over 6, root 3 over 3. Then I have 1 minus tan pi over 4. It's 1 times tan pi over 6, root 3 over 3. Okay, I'm running out of room, so I'm coming over here. So I am now at 1 plus root 3 over 3 over 1 minus root 3 over 3. Now, Next thing is like, okay, I have fractions in there. How do I get rid of the fractions? Common denominator, but I would still have fractions with the common denominator. No, because there's two things I'd have to FOIL because there's a plus sign in between. Yeah? If I multiply by the reciprocal, then I still have fractions though. Well, here's actually the reason why this is a 10 out of 10, because now we're even at, but all you have to do is multiply the top by root 3 and the bottom by root 3. You'll see. Just play along. Okay, watch this. We're distributing this, right? What is root 3 times 1? That's root 3. What is root 3 times root 3 over 3? That turns out to be 3 over 3. You start to see where I'm going to now lose my fraction. Because 3 over 3 is 1. Okay, if I multiply this out, this is going to be 1 minus 3 over 3. So this equals root 3 plus 1 over 1. Oops, sorry, that's root 3. It's root 3 minus 1. Okay? And then that's waiting for you in the multiple choice. You're like, oh, awesome. Because we forgot that they were looking for cotan. So this is tan, right? So cotan would equal root 3 minus 1 over root 3 plus 1. Because remember, if we go from tan to cotan, we need to switch. Not a long question, but man, that one's tough. Okay. Now, a couple quick ones. Now they're giving me the long part of the, and I'm supposed to figure out what's the answer to this. Well, what's sine 100 cos 10 minus cos 100 sine 10? Now I know I'd just put it in the calculator and I'd get that, okay? And you would. You'd get the answer. Unless it asked for exact value, then you probably won't. Okay? So which one of these formulas would you say matches up? Sine A plus B? Sine A minus B, because there's a minus sign. So, if this is A, this is B, this is A, this is B, so this would be sine, remember it's sine A minus B? So that is sine 100 minus 10, which equals sine 90 degrees. Which equals 1. B is a tough question. Which formula would you use? Cosine? Plus or minus? Plus, right? So I'm going to use cos A plus B. Do you agree with that? Because if you look in your thing, there's only one that goes cos minus sine. Okay? And that's cos A plus B. Now, what's A? Yeah, it's all of this is A. Right? All of this is B. And all of this is A. And all of this is B. Right? So the entire thing. Like, that's tricky. So now it is cos big bracket. A is 1/4 pi, or 1/4 pi minus theta, and that is minus, plus I should say, 1/4 pi plus 0 theta. 1/4 pi plus theta. Now what happens? Nicely, do you see how I have minus and a plus? They will cancel. This is cos 1/4 pi plus 1/4 pi. This is cos, what's cos 1/4 plus 1/4? 1/2. The answer is cos theta is what? Oh, that's actually pi over 2 for those people that... What's theta? What is the answer? What is cos at pi over 2? 0. Theta equals 0. Okay, example 5. I'll bet you will be on the diploma. I bet you will be on your unit exam. I bet you will be on your quiz. This is the question that you need to know your all last unit to do. It says if cos A is 3 over 5 and cos B is 5 over 13, and it tells you where A is, it's between 0 and pi over 2, and it tells you where B is, between 3 pi over 2 and 2 pi. No, 0 and pi over 2. We know that as quadrant. This is quadrant 1. And what is the other one talking about? Quadrant 4. Okay? Now, it asked us, what is cos A plus B? So I look at my formula, just like you're looking at your formula now, cos A plus B. That's cos A, cos B. Hey, they gave me what cos A equals and cos B. Oh, crap. Sine A minus and sine B. I do not know what sine A is, and I don't know what sine B is. Okay? Again, this is like next to impossible if you don't know just how to do it, right? Which is kind of characteristic of this course. So what I'm going to do is I'm going to find sine A and sine B. Okay? So just so you know, it's cos A plus B equals cos A cos B minus sine A sine B. So cos A plus B equals, cos A is 3/5, cos B is 5/13 minus, this is what I do not know, or I could find, well, what cos A plus. Now, do I know what A is? No. But I know what cos A equals. So I can substitute it right in there. The challenge now is to go find what is sine A and sine B. So once you've seen this, you go, okay, well, I could do that now. The first thing says do this in quadrant 1. It says in quadrant 1, cos A equals 3 over 5. So you want to draw a triangle. 3 over 5. What sides is that? It's cos A. X and R, right? Now, do you see how I could find, now this is angle A. Do you see how I can find sine A if I wanted? Sine A is y over r. Can I find y? Yeah, I can using our buddy Pythagoras, right? So if I went 3 or 5 squared minus square root 5 squared minus 3 squared, I get the answer 4. It's a 3, 4, 5 triangle, okay? So now I know that this is 4. So what does sine A equal? 4 over 5. I now know sine A. Next one. What is, so cos B, and it says that for B I'm going to be in between there and there, so I'm in quadrant. Okay, draw a triangle, and then I got to do 5 over 13. So that's 5, and that's 13. Again, if I have y, then I can find sine. So to do that, I would go square root 13 squared minus 5 squared, and I get 12. So then you put 12 here. So what is sine A, or sine B? So sine B equals 12 over 13. Yeah, that's the crappy thing about this question. When you get that 12 and you put it in, just by looking at the picture, what should be the sign on 12? It's a negative, right? Like how you gotta come up with ways that the province gets 65% in this exam, right? They need a 65 average. That's what they always get. So you're not going to get 65 average unless you're throwing down questions like this. So this is negative 12 over 13. Okay? That changes things considerably. So if you multiply these two together, you get 15 over 65. Minus, if you multiply these two together, you get negative 48 over 65. Now when you have a minus negative, that's a plus. So 15 plus 48 is 63 over 65. Now, if this was a written response, they would have, it is A over 65. Put A in the boxes, right? Because I know that the big one people would get is they would put that as a positive 12, and then they will be going 15 minus 48. Yeah, in that case, yeah. You know what? In that case, you have people going, like the biggest blessing you could ever have in a diploma, besides getting the right answer, is getting the answer so long that it's not a choice. No, it's true. When it is a choice, you take it and you feel good. When it's not a choice, you go, ooh, I did something wrong, I better go check that over, right? So, it's kind of like they say that the worst lies are the ones that are closest to the truth. Like if someone says, yeah, I'm going to the moon tomorrow. People don't get offended by that. But when you tell a lie that is really close to the truth, just a couple things different, people get really mad when they find out that. Think about that. The worst lies are the ones closest to the truth. I don't have a quote website testing. Okay. 1 to 3 ACE, 4 to 11. I made up a quote many years ago, and now it is everywhere. No. But it's been picked up. Here, watch this. I'll even Google it. Okay. You got to put in. Oops. Oh yeah, I'm recording. God.